Hey guys, we're going to learn solving systems of equations. Our goal is to get to 3 equations and 3 unknowns. We're going to start with 2 and 2. So the way we're going to learn that is graphically tonight in this video and by substitution. And of course we'll get lots of practice with this, and then eventually we'll learn elimination. Okay, so a system of equations is 2 or more lines that are graphed on the same coordinate axis. So on page 18 in your workbook, it does ask you to match up the letters in the graph. So I've already done that for you. The equation C, these two equations graphed together look like what you see in A. And what happens is there's actually 2 lines here. It's just that they're sitting one on top of the other because these happen to be the exact same line. They don't really look at it like it right now, but if I were to multiply the top one by 2, watch what would happen. I would have, or I'm sorry, negative 2. I would have negative 4x, I would have positive 6y, and I would have negative 6, which is exactly what this equation is. So through playing with it a little bit, I figured out that it's the same line. So what that means is I have one line graphed, and then I have another one right on top of it. But in this, the way this picture looks, it looks like it's only one black line, but it's actually 2. Okay, the next one is what we call parallel lines. They have the same slope. The way to determine that is to solve each of these equations for y equals. So I would do that by, I'm keeping this term here and I'm moving the 2x over. So it'll be negative 2x plus 3. Then I'm going to divide by negative 3. So when I do that, I'd have positive 2/3 x minus 1. Now when I graph this, when I do the same thing to this one, I'm going to keep the 6y and I'm going to move the 4x over to the other side so it becomes positive. And when I divide by 6, what happens is I have 4 over 6, which reduces to 2/3, and then plus 1. It doesn't really matter about my y-intercepts. What does matter is that my slope of 2/3 is the same. That's what gives me, see, 2 different y-intercepts, but the slopes are the same. So this is a special case. A and B are both special cases. All right, and then what happens in C is these are just 2 totally different lines, 2 y-intercepts, 2 different y-intercepts, and 2 different slopes. Okay, so why do we care about that? We care about that because that determines how our answer is. So in the case of A, when I had one line and then another one right on top of it, I'm looking for I'm looking for the points of intersection. So that's what it means to solve a system, is the intersection points, or point. Usually, more times than not, it's going to be 1 point. Okay, so in A, what happens is I have a point here, I have a point here, I have a point here, a point here, a point here, a point here. So in that case, that's called infinitely many solutions. And in class, we will write that as IM. Infinitely many solutions. There are infinitely many points on the first line and infinitely many points on the second line, and they are intersecting infinitely many points. Okay, so in B, what's happening is this line that has the same exact slope as this one will never, ever, ever touch. So if this goes on forever and this goes on forever, they will never touch. So that is called a no solution. Okay, and then those are what you call special cases. They don't happen very often. So the one that happens more often than not is in C, where you have 2 different lines, and what happens is they have 1 point of intersection. And so we're going to just label that point of intersection as 1, 2, 3. X value is 3, the y value is 1. So on this page 19, you should be able to actually find the points of intersection. So they've already been graphed for you. Your job is to just figure out the points they've been intersected at. So you're welcome to pause the video and come back and look at it, but this point would be, this final answer would be the point 2, 1. B would be the point -2, +1. And C would be the point 1, looks like -1. Oh, whoops, I don't know what I was doing there. 1, -1, because we were looking for that point right there. Sorry. Okay, next I'm going to show you 2 examples. Again, you want to write those in the notes that you have. There's not a whole lot of room, but we're just going to do 2 examples. Please feel free to stop and back up the video at any point that you need to. And then rewatch it maybe after you've gotten your notes down. Okay, so what happens is when we solve graphically, I have both of these already set up for you in y equals mx plus b. If they're not in that, we have to get it that way. All right, but right now I'm just trying to make it easy for you. So we're going to start by graphing the y-intercept. Hopefully you already know how to do this. So we're going to go up to 3 and put a point. And then our slope is 1/2, so that means rise 1 and run 2. So we're going to rise +1 and run 2. Now you really need to have a ruler. So when we do these in class, it's very important to get a correct answer that we have the straightest line possible. Unfortunately, I don't have a way to do that here, so I'm just kind of guessing, but we should be doing it with a ruler. All right, and so I've graphed that one line. Now I need to graph this line. So I'm going to go up to 1. This is my system here. And then this will be -2/1. That's rise. Actually, we're going to fall because it's negative. So we're going to go down 2 and right 1. Okay, so when I draw this graph in, this is why we need a ruler. So anyway, in class, we'll make sure that we have a ruler, but what you're looking for is the closest place that they intersect. So if I had done this with a ruler, it would probably have intersected right here at -1, 3. So the answer to this solution, to this system of equations is the point -1, 3, and that's all by approximation because again, I don't have a ruler, so I'm getting as close as I can, and I was going to use that point right there. Okay, the next way is called substitution, and it means exactly what it says, substitution. You're going to substitute something for something else. So you always have to have, in order to work substitution, you have to have one of your equations, either this one or this one, has to be solved for either y equals or x equals. In this case, this equation is solved for y equals, so it's set up perfectly for me. So what I'm going to do is I'm going to take what y is equal to, and I'm going to substitute it into the other equation for y. So this thing right here is going to go in right there. All right, so let me try to color coordinate this for you so it makes sense. So I'm going to write out the first one, 2x plus 3, but where I get to y, I'm going to substitute y because it says that y is equal to -2x plus 1. So I'm going to substitute this y for -2x plus 1. The rest of the equation, all the part in black, all stays the same. All right, and then this is where your algebra skills have to kick in a little bit. And I'm going to distribute the 3, so I would have -6x plus 3 equals 7. This would give me -4x from here. Plus 3 equals 7. I'm going to subtract 3 to both sides. So I would have -4x equals 4. Therefore, x is -1. Okay, so remember the answer to a system is always a point. So I need to have an x value and a y value. So far, I've found my x value to be -1. So I'm going to put that in the x spot. Now I have to do a little bit more work because I do need to get that y value. So I just pick one of the equations. I'm going to pick the one in the bottom because it's already solved for y equals. It doesn't matter, you can plug it into either one. But I'm going to take that equation, and since I know that x is equal to -1, I'm going to substitute again. So I'm going to take this x here and I'm going to substitute it with -1. Okay, so then that's going to give me +2 plus 1. Another reason why we learned order of operations again, so you can do this well. So then y is 3. Okay, so that means that the point that these two lines intersect at is the point -1, 3.